H51 simultaneous equations with two variables. Now the difficult part for these questions is that we have fractions involved. So in algebra, we do not like fractions, so we need to get rid of them. How do we get rid of fractions? We multiply by the LCM. So the LCM of equation 1 here is 6, because the LCM of 2 and 3 is 6. So we multiply equation 1 by 6. So the way you do that is 6 divided by 2 is 3, multiply the top by 3. 6 divided by 3 is 2, multiply the top by 2. So that gets rid of the fraction, then multiply out your bracket, and then tidy everything up, bring your x's and y's to the left, and your number goes to the right. Same in equation 2, our LCM here is 3 because there's just one fraction, but we have to multiply everything by 3. So this multiplied by 3 would give you x, and then this multiplied by 3 would give you 3y, and this multiplied by 3 would give you the minus 15. So now we have equation 3 and equation 4. So from that point, it's just your normal simultaneous equation using those two equations. Okay, so step 1, in question 1 here, get rid of the fractions. So always number your equation. So we're going to multiply equation 1 by 12, because that's the LCM of 3 and 4. So 12 divided by 3 is 4. Put whatever's on top inside the bracket. 12 divided by 4 is 3. Multiply that by what's on top. So that would equal 4x minus 4 equals 3y. But remember, we want the x's and y's on the left of the equal sign and the numbers on the right. So we're going to bring this over there, and we're going to bring the 4 over there. So that would equal 4x minus 3y equals plus 4, and I'm going to call that equation 3. So then we're going to do the same for this equation. The LCM is 2, because that's the only fraction there. So equation 2 multiplied by 2 would be 2 divided by 2 is 1, multiplied by x is just x, equals this multiplied by 2 plus this multiplied by 2. So bring the 2y over, so that's x minus 2y equals 6, and that is going to be equation 4. So we're going to do a simultaneous equation with these two. I'm going to cancel the x's because you've just got a single x here. So if we multiply equation 4 multiplied by 4 equals 4x minus 8y equals 24, because that then allows us to cancel the x's using these two, change the sign of these so that our x's cancel. So 4x minus 4x means they're gone. Minus 3y plus 8y is 5y, and 4 minus 24 equals minus 20. So our y equals minus 4. So I would recommend plugging this back into one of these two equations because it's easier than trying to plug it back in up here. So I'm going to take this equation here and plug it back in. So x minus 2 multiplied by minus 4, because this minus 4 is replacing this y here, equals 6. So that would be x plus 8 equals 6. So x would equal minus 2. Then you'd verify that. So x equals minus 2, y equals minus 4. So you verify that by plugging those back in here. The left hand side would be here. That's minus 2 minus 1 over 3, which would equal minus 3 over 3, which equals minus 1. And plugging this onto the right hand side, so that's minus 4 over 4, so that would also equal minus 1. So they are the same. Do the same then to the second equation, left hand side. I'm going to plug our x value in, so that's minus 2 over 2, which equals minus 1. And the right hand side would be minus 4 plus 3, which also equals minus 1. Okay, so you only have to verify on that question. You don't have to verify these, but I'll just get you started with this one. So number your equations. LCM of the first equation is 12, so equation 1 multiplied by 12 would equal 12 divided by 4 is 3 outside of what's on top. 12 divided by 6 is 2, multiplied by what's on top. That would equal 3x minus 3 equals 2y. Moving what you need to move. 3x minus 2y equals 3. call that equation 3. Do the same for the second one. LCM is 3. So 3 divided by 3 is 1, multiplied by x is 1. So you're multiplying equation 2 by 3. That'll be x equals 3y minus 27. So x minus 3y equals minus 27. That's equation 4. And then you do a normal simultaneous equation from that point.